everybody, welcome back to another Hints to Help video. This one's nothing too complicated. It's more like a whole bunch of information about Big Ben. So if you're familiar with Big Ben, the clock over in London. So as you read through all this stuff, it's just kind of information about it. The key thing is this length right here. So the fact that it's a 4.4 meter long pendulum. So to find the period, you are just using our period equation. Going to be 2 pi times the square root of L over G. You've got L, G, we're just going to use our normal 9.8, and that'll find the period. Now, question B is kind of, this would not be appropriate. So the question is, what does that mean? Well, if I think about it, if I make a pendulum and I want to use it for timing devices, what I would love is for it to swing over here in 1 second and then swing back in another second. That way, every time it swings, that would count as a second. So 1 second, 1 second, 1 second, and so forth. And other ones that would be appropriate would be if you double this, like if it was 2 seconds and 2 seconds, if it was 3 seconds and 3 seconds, if it was 4 seconds and 4 seconds. So we would need those whole numbers for it to actually kind of make it back and forth. And what you're going to find when you solve part A, that's not going to be the case. And then C is kind of just my normal question. What do you think would be some reasons for this? One of the things that we haven't really discussed is this is actually what's called a physical pendulum, which means it's a solid bar that's swinging back and forth, and therefore where its center of mass kind of affects things, and it swings slightly different. So when you have a solid object that's swinging back and forth, that actually swings differently than if it's a string or a wire or something thin that has very little mass, and you basically all the mass is at the bottom. So that's one of the ideas, but there's a couple of ideas that I think you can come up with to answer part C. Hope that helps.